Hi, Jerry.
Good evening, everyone.
Good evening.
How has everyone been? How did you find the class so far?
So far, so good, Jerry.
Really good.
Enjoyable.
Sounds excellent. So can one of you volunteer to summarize what we have learned in the past week?
Steven.
Thank you.
Good recommendation.
So
I'm told.
I'm still going through the videos, but we're now learning about multiple regressions. So we're learning about adding more independent variables and how that impacts the model, as well as incorporating dummy variables and curve fitting. Yeah, is there anything else that anyone would like to add to that?
Thank you, Steven. I'm sorry, calling.
It seems it works quite well if I lighten up myself. Although it's, good summary. What we learned in the past week builds up on the previous week, where we basically manipulate more about linear regression. We add more predictors and make some specifications in special cases where we have categorical variables as predictors. So thank you, Steven. And it seems you have did pretty well in reviewing the content in the past week. So how has everyone found about whether what we are learning is useful, maybe at work?
It's been good for me.
Well, good to hear.
I was not expecting to use on the work because I'm still at home, but I just feel like it's very useful. Like these modeling can help us to predict a lot of like data in the future. So I'm so excited, like see in the future after we finish this class, we can build up our own model to predict something.
Yeah, well, I hope you will find the course learning useful at work in the future. All right, I noticed that I received some messages from our class about homework 4 question. And now it's a good time for us to preview homework 4 and let me know whether you have come across any questions. Has any of you started working on homework 4?
Yeah, I actually do have a question regarding to the problem D.
Okay. There are also 2 questions. So are you working on problem 1 or 2?
Oh, you want to go through the order? Oh, let me see. Oh, I just want to clarify, see, is my wording for the slope explanation, like interpretation, it's actually accurate. So in the future, I would just make sure it is correct. So let me put on the chat. So
are you actually asking about part C in problem 1 in assignment 4?
No, I just just the problem A. But I can do that like the problem C because it was just it actually has 2 slope.
Oh, all right.
Yeah, but but I was just wondering, like, when I explain it, I just explain each slope because that's how. Just let me put on chat. Let me see, where's the chat? Everyone.
All right, let me see.
Yeah, that's actually from problem 1, number C.
All right. So we are working on problem 1, part C. Yeah, in assignment 4 for other students. So Ziyi has supplied a candidate answer for slope interpretation. She said that slope of the newspaper advertising in the regression model is this much, which means that we would predict an increase of these many dollars in weekly gross revenue for every additional dollar in thousands spent on newspaper advertising. Yeah, looks great.
Oh, okay, that's
yeah,
great. I just
everything. I guess you could simply say like for every $1,000, or there's an increase of $1,945. Yeah.
Oh, okay. Yeah, that's actually easier.
All right, and remember these this effect using coefficient is predicting the expected value. So that you're very sure that the effect is assessed on the mean or expected value.
Can you repeat one more time?
Oh, I'm just highlighting that the slope measures the effect on the mean or predicted value.
Oh, okay. Yeah. And also, I do have a question on the equation though. Like, for example, on the question, like a problem 1 and D. So I'm just wondering, when we writing the equation, we do have a standard error on like in the end, right? But
yes,
when we calculate
hold on there. It's not standard error. It's just the error term.
Oh,
these are different. Yeah, an error term is different than standard error. These are two different things. Yeah.
Oh, okay.
So, yeah, so in regression equation, you're right. We do need to include the error term.
But when we calculate it, we actually ignore it, but I don't know why.
Why? We actually discussed it last time. Maybe you couldn't recall, but here is the reason. Remember that when we do linear regression, we have an assumption saying that the mean value of the error term equals 0. And we actually use this to optimize the algorithm to get the estimation results for linear regression models. So this assumption is actually guaranteed. You will never find a regression result where this error mean value does not equal to 0. So that's why when doing predictions, we can we know that the mean value of the error term equals 0. So that's why we didn't ignore it. Because when we predict, as I said, the predicted values are about the means. So that's why when we take the mean of the error term, it equals 0. So when we sum up, this part is somewhat considered, although it's 0. So it's sort of, its effect is not shown.
Oh, I see. So because, I see what you're talking about. Thank you so much.
Excellent.
Hey, Jerry, I had a question on
Hi, Mark.
Part E about explaining the slope.
All right. What's your question about?
So, you know how it yielded a R square of like 63% or something, explaining the variation. My question was, if it's a higher slope, does that mean that, so one of them was like 1.9 and the other one was 1.2.
Yeah.
I was wondering if the newspaper, in this case, the newspaper advertising, because it has a higher slope, has a higher like effect on, higher influence on the weekly gross revenues.
Oh, yes, correct. So the estimated coefficients, as you suggested, is the effect of increasing one of the advertising investment by $1,000. So if one of the coefficient is larger than the other, it means the effect is larger than the other. But these effects are assessed when controlling for the other one. So what it means is that when, there are two types of advertising expense, right? One is television, the other is newspaper, and we are assessing their effects on the revenue or the sales, right? So when we talk about the effect for television advertisement using this model that we had developed in Part B, we are controlling for the effect for newspaper. So that means when we describe the effect, we should say that holding newspaper advertising expense constant, then adding $1,000 in television advertising would increase the revenue by this much.
Okay.
Yeah, so it's great that you're now comparing two coefficients. However, in the future, we will also learn additional on this aspect. When we compare two coefficients, there's also an aspect of statistical significance to consider. As you know, as you described, you found that the television advertising effect coefficient is about 1.2, and newspaper advertising is about 1.9. So do these two coefficients actually differ from each other very significantly? It still remains a question to be resolved after future learning.
But can you also say that the independent variables, when measured against gross weekly revenue, when together, they show a stronger relationship to weekly gross revenue?
Oh, sorry, I didn't catch this question part. Could you repeat your question, Mark?
Oh yeah, sure. I was asking if when you have, a single regression and a multi-regression, if those variables don't relate to each other, then will always produce, like, because from the lecture, it said that the R-square would always increase when you do a multi-regression. So it doesn't necessarily mean that those two variables influence the Y variable, right?
Sorry, I'm still not really sure what you're asking. So you were trying to compare a scenario where we had one predictor in the model versus another where we have two predictors in the model, right?
Yeah.
And what was not clear for you in between the
oh, no, nothing was not clear. I'm just saying that is it always going to be like, is the R-squared always going to be higher than what it was?
Yeah, okay. R-squared will be higher.
Okay. And I ran the single regression for.
Oh, you actually did?
Yeah, I ran the single regression for the other variable, and that had a higher regression that had a higher R squared. So that R squared has more impact or more influence on the weekly gross revenues.
Oh, sorry. All right. I think it might be much more useful if you could share your results with us. I
Sure.
don't think if for question 1 you had tested your own simple linear regression model using only one predictors, you could actually get a higher R square than what we have using 2 predictors. I don't believe it's possible.
Oh, I was saying that the R squared is like 72% for the newspaper, not newspaper, but the TV, and then the other one, the newspaper, was 63 in variation.
Oh,
40%. Oh, anyway, let me show you my screen.
So yeah.
I can't share my screen. So.
Oh, right. Let me enable it. Here you go. Now you can do so.
So this is the newspaper version.
Yeah. Mm-hmm.
Then
Looks good.
And then I ran the TV one just for fun.
Oh, okay. Yeah.
And then I ran the double linear.
Okay.
Multi-linear regression. And I was just wondering, the TV, it has a I squared of 52%.
All right.
And the other one has a 40%.
Okay.
So
yeah, I got it now.
The regression has to be at least higher than 52% for the multi-regression, right?
Mm-hmm.
And it is. So basically, but what can you gather from that? Like when you combine them, right? Since that has 52% and the other one has 40%, can you gather that the TV advertising has a higher, like more of an influential impact on gross weekly revenue?
Oh, okay. I see what you mean here. All right. So Mark here has a very interesting question that's not typically addressed in any statistical, textbook. That's to assess the, strength of a variable in predicting the dependent variable. So yeah, Mark did a very interesting experiment to run simple linear regression before a multiple linear regression. And he found that the TV advertising, when regressed alone, has a higher R square than newspaper advertising regressed alone. Then when we combine them together in what we did in part C, I believe, in, part B, in problem 1. So could we tell anything using what we learned from the simple linear regression? Here it emerges 2 ways of comparing the effects or the strength of effects in linear regression. So first one is that we can compare the coefficient estimates directly. Simply, we can compare the numbers as coefficients from television, 1.2, to newspaper advertising, 1.9. So we could say when we put $1,000 through TV, then it gets us less revenue than if we invest the same amount, $1,000, in newspaper. However, this there's another way, a second way we can compare the size of effects on the dependent variable. This is especially useful when the unit of the predictors are different. So instead of advertising expense, we could find possibly insert another set of variables saying, for example, the number of staff managing marketing. Yeah, so we could assume that if we put more labor in marketing, then we could also expect a higher revenue. However, the unit of assessing staff is, for example, the hours worked. It's quite different than expense, which is assessed in dollars. So how could we possibly compare the size or importance of these variables? There's another concept called variance explained statistics. So R square is one of them. But when we assess the R square contribution in multiple linear regression, there are certain ways to separating this the R square, which is here we find to be 0.73, right? Between each of the predictors. There are multiple versions of it, so it'll be more advanced statistics, and it also involves adjustment between the ordinary version and the corrected version of it, and there are all sorts of papers published about which one would be more accurate or more reliable. So that using this variance accounted for or variance explained measures, we could compare the importance of predictors, especially when the units of them are different.
Thank you, Jerry.
So did this help address your question?
Hi, Jerry, it's Christelle.
Hello, Christelle.
Hey. So my question is, could you just guide us on how we can formulate the formula for articulating a formula for when a slope increases? Like 4 of the questions in problem B, I think, or 2 of them, ask us what would happen if something increases. Could you just kind of guide us through on how to do that?
Okay. Are you actually asking about maybe part E, not part B?
We could do problem 2C.
Oh, all right. Let's see. In problem 2, we have income and life satisfaction. And in part C, we need to use our model to predict what change in the life satisfaction score is expected if the income increases from 80,000 to 90,000, right? So in this model, we are using both the original and squared version of the predictor, that's the income. So we, for asking, when addressing this question, we simply compare the predicted value of life satisfaction at both values of income, that's 90 and 80,000. Then we take a difference, then that's the change in life satisfaction score. Did I make myself clear enough?
Not sure, but I think it helped.
So did you already work on this question? Did
So,
you have any clue in doing so?
Yeah, so when you mentioned that you're really trying to get the predicted value for two incomes, and you're just subtracting the difference, and that would be the life satisfaction score. Is that right?
Yeah, correct.
Okay, got it. Okay, that helps. Thanks.
Hey, Jerry, for number 2, part E, I'm just having a hard time setting that model up.
Okay. Are you asking about problem 2 or 1?
Problem 2, part E.
Okay.
Steven,
yeah,
do
the
you
question
mind
is
I
quite
jump?
long.
Sorry, go ahead, Alyssa.
Do you mind he answer my D first? Can we go in order?
Yeah, we can do go in order. Yeah, no problem.
Yeah. Just I have a question with like it says in the D problem 2D it says why is the answer different from the one is part C, and then does this difference make sense give what you saw in the data in part A? I'm just don't know how to wording it. I did all the calculation.
Okay,
like,
you did. Excellent.
Yeah.
So what's your wording now? I'm just curious.
No, I just suddenly blanked. I just don't know what he's really asking me about. Like,
okay, so you're not sure what this question actually means. Would you mind taking some guess at this moment?
Yeah, so maybe it's just talking about because they are actually from two different simple linear regression model, like a equation, right? Like a thing, yeah. So that's why, and also it's from, so their equation is different though. So yeah, that's what I'm thinking, because it's piecewise linear model. So they have two separate, there's a range difference, right? I just don't know how to.
Sorry, no, I think you actually went further step in E already when you tried to address part D.
Oh.
So no, there's not a piecewise linear regression up to part D. You could call the model you developed in part E as a situation of piecewise linear regression. So, but in part D, we are assessing the change in dependent variables at two segments or around the same curve. So because the curve, the slope changes along the curve, right? Because it's a quadratic function. That's why we would expect the effect or the change in life satisfaction to be different, although from the same difference in the independent variable, but at different values. So notice that the difference in the income from 80 to 90 and from 180 to 190 are both $10,000, right? But they are at different segment of the quadratic function. So that's why the changes changes in the life satisfaction would be different.
Oh, okay.
Yeah. So this is the distinction between linear and a simple linear, ordinary linear model and linear models with the higher orders, like a quadratic or cubic function in it.
Oh, so this is the one that we do in the what I call polynomial, nominal.
Yes, polynomial terms.
Yeah. Nominal.
It creates curves instead of straight lines. So that's why the slope along the curve would be different on different segments of the curve. If we had a straight line, where we do not have any higher order terms or polynomial terms, or maybe you call them quadratic or cubic terms, then the slope is simply for a straight line, which would be the same slope along any segment of the straight line.
Oh, I see, because there are two segments over there. Okay, I think,
Wonderful.
thank you so much. That's very clear.
So that was part D. And just now, let
Thank you,
me
Stephen.
get back to Stephen then. You were asking about part E, where we are instructed to construct a dummy variable. So have you already tried doing so? And please share with us your
Yeah, I did.
effort and results so far.
Sure. I did give it a shot.
Oh,
it's a little
alright.
messy
Well,
probably,
let's
but
go.
we can take a peek. So this is what I've got for the table.
Okay.
Then I tried graphing it similar to the earlier parts, and this is what I came up with.
Wow. Okay. This is the model you got in the first part of problem 2, right?
Well, this is the first one that I got up higher. This is the first one I got. And then this is the second one for part E, based off the table that I tried to create with the dummy variables. This is the model that came out from that table for part E.
Okay.
So I don't know. I don't think I'm doing it right. I feel like it's just not.
No, unfortunately not. You
okay.
did not do part E correct, but oh, I see.
Yeah, this is my
interesting.
table.
The reason is that you also need to include the interaction term in the in part E. So you're missing one of the predictors. You need to use 3 instead of 2.
Okay, so would it be dummy interaction or income or?
All of them. Yeah, you should use income plus dummy plus interaction.
Okay. And is this done correctly? Low equals 0. And then I did 0 times life satisfaction for interaction.
Could you say it again? Let me take a look. Yeah,
sorry. So it asked to separate for high, low income.
Okay. Yeah.
So for income, I put low and then high based on the median. And then for the dummy variable, 0 and 1, 0 is as low, 1 is high. And then for the interaction, I did the dummy variable times the life satisfaction score.
No, this part of setting interaction is incorrect.
Okay.
The interaction should be the interaction between dummy and the predictor. That's the income.
Okay.
Yeah.
Okay. Got it. Okay.
Yeah, others look right. I'm not sure whether Excel actually takes text or words as predictors. So in part E, we need to include 3 predictors. That's the dummy, interaction, and income. So I think it's safer to use column B, C, D as predictors in part E instead of A.
Okay.
But you could also test whether using A actually makes sense. But if you used column A, then as one of the predictors, then you do not include the dummy again, because column A and B at this moment include the same information.
Okay.
Steven, your row 26, I think is supposed to be dummy 0, because your mean is 144. It's supposed. Is it correct?
Yeah, it's below the mean.
Uh,
Right? Oh, yeah, that's correct. Is it?
Is it below the mean? So it's supposed to be 0.
Yeah.
Wow,
Damn, thank you.
great. I didn't even notice that.
but,
I guess it makes a tiny difference when we, in terms of the model output.
Oh, whoops, I fucked it up.
But Jerry,
Yeah.
can you teach me how to, or Stephen, I don't know how to make a scatter chart for this.
Did you mean scatter plot?
A scatter
When
plot.
we have the points to represent X and Y?
Yeah, for some reason I got very weird graph.
Okay, so can I have Stephen run a scatter plot again, and maybe on the model if, oh, I see, yeah.
Yeah.
Maybe if from part A, because that's easier to understand without having interactions.
I know how to do one. I know how to do the regular one, like the simple linear, but
Oh,
for there's I don't know what column you supposed select in this graph, like when you have interaction and a dummy. Can you
You're asking about 2E as well, Alyssa?
yeah, it's just like how to make a graph, like the scatter plot with all these variables.
right. Do we need to make a plot?
No, we don't
part
need it. I'm
B?
just wondering.
Ah, I see. So if you actually want to add the trend lines, right, on the graph, is that what you actually wanted? So
No,
you
because I
can.
think I couldn't even make a graph. Like my
You couldn't?
plot, it's
Okay.
all like either line up or
Ah, I see. Then I guess the question is actually simple. You were just wondering which series of data to plot, right?
yeah,
You
yes,
still
yes.
plot X and Y, which is income and life satisfaction.
Oh, so you don't use all these dummy interaction?
No, yeah. Those dummy variables and interactions are only useful if we wanted to add trend lines on the plot.
Oh, now
Yeah.
now I know. So,
So
if you use a
remember-
dummy, it will be using the different kind of train line, right?
Yeah.
Oh, okay. Now I get it. I remember now. Okay, thank you. Let me do it.
Oh, thank you, Stephen.
Thank you, Stephen.
Question is already resolved. And yeah, it's great that your each of you is very considerate for all different situations. And to me, it appears to be a great motivation for extra learning.
I think I'm still blowing this, Jerry. I don't want to eat up too much of the time if others have questions.
All right, how can I help here?
Does anyone have any questions before I get into this with Jerry?
Actually,
is it a
I
very
think my
challenging one?
question, I think my question is kind of stemming from Stephen's question as well. It's problem 2B.
Okay.
It's where we create that model. And so I'm not sure if I'm supposed to create that scatter plot or the output summary. Because if I do both, I get different R squared. R square.
Really?
Yeah, I don't know why.
Hold on. Oh yeah, I guess the reason is maybe you have done the part B summary output of linear regression correct. If that's true, then when you have the scatter plot and the trend line, maybe you selected a linear trend line instead of quadratic. So there are multiple versions of trend line you could add to a scatter plot. Make sure you add the correct one.
So
you
put
add the
polynomial.
yes.
So
and I'm not sure. I guess you also need to include how many, what order you want the polynomial to be.
Wouldn't it be 2 since we're doing quadratic?
Yes, it should be 2.
Should I show you what I have?
Oh yeah, that'd be great.
Oh, actually, I'm not ready. I have to join from my other computer. Steven can,
All right.
someone else can.
You could come back when you have your computer connected.
Yeah. I'll join
Yeah,
from
so
but someone else can
I
ask.
guess the reason you had different R square is that when in the scatter plot, it needs some more specification of the trend line polynomial order.
So would you say that the output summary is really the accurate?
Yeah, it
I mean, I guess it
includes
depends
more
on what variables you put.
Please include the summary output in your report so I know immediately whether you run the model correct or not. In assignment 3, I noticed when some students had wrong answers for some of the questions, but I'm not sure why. So some of the answers are correct, some are not. So I couldn't tell the reason if the summary output was not included in the report. Yeah, so please include the summary output of regression results. So if there's any comments I could add, then I could make the comments more useful for you. So any other questions? All right, Stephen, I guess you have one. Is it? Sounds it's probably challenging. Let's see whether I can.
Yeah, no problem. I'm still stuck on part E to question 2 part E. So I tried to regraph it.
Okay.
Here. I actually got the same equation as before, but I highlighted the columns you suggested and.
Oh, the graph. Is this graph supposed to be piecewise? Like there's two single linear? Or my equation is different from yours?
For E, Alyssa?
Yeah.
What did, okay.
Because he told me don't select other dummy and interaction, right? That's what he said, right? Only choose the variable, like the independent variables for incomes, and then choose the life certification, right? Is that what he said?
I got the same as Steven, but again, my question is if I do the output summary, I get a different answer. So I don't know which one's correct.
Oh, interesting. Okay. Yeah, because when I plugged in the equation for the following questions where it asked, for the change in score, this is what I got when I plugged it in.
When you guys do this, I didn't do the graph. That's why I used just the regression model. I did get different one. Did you?
Oh, you did. Okay.
The 7.4995 plus 0.425, something like that.
So could you pause there a little bit? I was trying to catch up. I didn't realize you shared the screen earlier.
No worries.
So Stephen, were you trying to make a plot for the break line regression, or were you trying to make predictions out of it?
I was trying to make predictions.
Okay, and are you working on part E?
Yes.
I thought part E is only about running a regression, but
oh, okay.
I don't think it asks for prediction until part F and G.
Right, right. I guess what I'm asking is this equation correct for part E? Because when I went to the next part F, and I tried to plug in for the equation that I got from part E, the numbers did not make sense. So it didn't seem like what I did in E was accurate.
Okay, I see. Then could you share your, I guess you're still sharing your screen. So yeah. Could you show me where you get your results for part E so I can see whether there's any
so I just pulled it.
Changes we need to make.
Here's the table.
Okay, looks good.
And then this was the equation.
Oh, I see. Hold on there. This equation is not the correct one for part E.
Okay.
The reason is here you're estimating the equation out of the scatter plot. which does not include the domain and interaction. Yeah, so because in this plot, you're plotting life satisfaction against income, right?
Yeah.
Or did you actually reverse it? I think you actually reversed it. So you should have life satisfaction on the y-axis.
I thought that's why I plotted it here. Yeah, life satisfaction Y.
Interesting.
Yeah, so it goes up to 90. That's how I plotted it.
Hold on there. Let me take a look. It doesn't make sense. As you can see, the income ranges between and to 200.
Right.
But there's no point on your plot that has a value roughly about 200. So
right.
Yeah, I'm not sure what happens if you select more than 2 columns when doing scatter plot. So there must be some secret selection algorithm for Excel that selects some of the terms instead of others when plotting. So for part E, use the linear regression function in Excel. Do not depend on scatter plot. The scatter plot is a convenient tool to visualize it, but it's not the best one for estimating models.
Got it. Okay, that makes sense. That's helpful, Jerry. I appreciate it.
Yeah, I'm not sure what selection Excel made for your plot, but this plot is not correct, and the equation associated with them is not correct either.
Okay, cool. I appreciate that, Jerry. Thank you.
No problem. Hi, Christelle. Did you already find
oh no
the results you were working on?
Oh, okay. So okay, hold on. Let me share that. And again, I think I'm asking the same question as Stephen, but that plot was more on for my for B. So when you say this fit a second order polynomial, the scatter plot that Stephen got is what I got, because that's the equation that I got.
Okay.
However, if I run the output summary, I don't know what I did there, then I get a different R squared for that. So that would mean a different equation. So that's why I was confused about, do I use the output summary or do I base it on the equation given by the scatter plot? Does that make sense?
Okay, yeah. So could you show me your summary output table again and on the page below?
Oh, here?
Yeah, let me take a look. Yeah, so as you can see, the results shown in your scatter plot and this in the summary output table are both different in terms of the estimate of the coefficients and the R square. So here, as I said, the summary output is correct, whereas the scatter plot is not. And one of the reasons is that the scatter plot is actually not correct. As I said earlier, the income should range between 500 and 250. Oh, sorry. The income should be between 50 and 250. You can check this in Excel series. But in your scatter plot, you showed us on the page, on the previous page, you can notice that this is not true for the x-axis.
Okay, so just stick to the
because
output.
the selection of the variables, we need to be more cautious to make sure that the income column is selected for x-axis, whereas life satisfaction is assigned to y-axis. And in the scatter plot you showed to us, this is not correctly specified.
Okay. Okay, good. Thanks.
Wonderful.
And is that because the y-axis is supposed to be dependent variable, right?
Yeah, hi, Samuel. Thank you for the question.
And that
Correct.
also means in this case, our dependent is satisfaction, right?
Correct.
Because satisfaction is dependent on the salary and all that other stuff. Okay,
Yes,
I got it.
correct. And also make a note that for scatter plot, it's most useful to assess the relationship between two variables. If you have multiple predictors in the model, then a typical way for data scientists is to have scatter plot for all possible combinations of variables. So for example, in part E, we were requested to add additional predictors. So in total, we have 3. We have a dummy to show the income level, low or high, and the income value itself, and an interaction between income level and the income value. So we have 3 predictors. In this case, when we make scatter plots, we could make at least 3 different scatter plots. We could have one between satisfaction and income value. We could have a second scatter plot, or we could have a second scatter plot between life satisfaction and income level, low or high. And we could have a third one, life satisfaction and the interaction term. So do not confuse between these 3 different predictors. A scatter plot could only assess one pair of relationship at a time. So do not try to make one scatter plot when you actually have 3 different predictors that you want to show the relationship.
So does that mean for that problem, you would want to see 3 plots?
No, it's not required. I was
Okay.
just adding to what Stephen was working on. He was trying to, seems to achieve this objective, but for assessing 3 different variables, but one scatter plot could only assess one pair at a time.
If there's no other question, can I ask you a question that's not related
Sure.
to work? Because
Okay,
I do
no
see a professor did a piecewise linear graph. I'm just wondering, is there any way we can do it? Like there's any secret buttons that we can click and get these graph?
Yeah, I believe so. So what you add to the plot would be reference lines instead of trend lines out of the plot.
Oh, let me see. So
you could add some reference lines in the plot.
So add chart reference line. I only see legend.
I haven't tried it myself, but I believe there should be a way to do so.
Oh, if any other people have questions, you guys can ask. This is not related to homework, so you guys can ignore me. If not, I'll just ask.
Let's see. Oh, right, I found it. So let's see what my example could help. So first, let me show you what a piecewise trend looks like. All right. So in part E, for of the problem 2, where we need to make include interaction terms, then we could possibly, let's see. Oh, so are you seeing the plot I have here with the green line representing the polynomial trend line and the yellow lines representing the broken straight lines.
Mm-hmm.
Yeah, so this is for a plot you could make out of part E. Part E asks us to break the line by income levels. So as you can see, the line breaks right at this part where the income is at the median level. So that income below this point, about $150,000, the line, there's one line, and above it, there's another line represented by the two different yellow lines. However, if we use the polynomial trend line of second order, then we see this smooth curve.
Mm-hmm.
So this is what a broken line regression looks like if we have a dummy and interaction in a model.
So we're gonna only including, we're gonna include in these three variables, for three independent variables and one dependent variables, right? That's what you said.
Yes. So I'm saying that the green line is the model results for part A, where you have where we have income and the square of income in a model. For the yellow lines, those are from part E, where we have income, dummy of income level, and the interaction between dummy and the income value. So the yellow, the two parts of the yellow line comes from one model where we have interaction and dummy in it. So it comes from part E. So we could add different trend line in a model in this way. So for example, in part, let's not add a trend line in the beginning. Okay, all right. So this is in the happiness problem B part. If we click on the dots, then we are sure that the plots are actually between income and life satisfaction. So as I said, one scatter plot is useful to assess the relationship between one pair of variables, right? So we could not really add square or interaction or dummy onto the same plot. If we want to plot the relationship of with other predictors, we need to make different scatter plots. So now let's add some trend line. So if we click on the plot, then right click on the format plot area, then we find oh, I guess we need to first add the trend line element. So we click chart design. There's add chart element, then we can find trend line. So as you can see, default is that there's no trend line. We could add a linear trend line where we ignore the square of the income at all. Or there are other versions like exponential, linear forecast, or moving average. You could try them for yourself, but these would not be relevant in our exercise this time. We could use add more trend line options. So we move to this trend line options. As you can see, we could add a polynomial of line of order 2. which corresponds to the problem we have in part A or B in problem 2, right? So this corresponds to the first model we run for problem 2. When we go to problem 2E, where we have broken lines, then we need to add this custom. Then if we add, I haven't worked on this myself before. So I guess you could insert as a line as
no worry. We can.
Yes.
You can let us know later, or there's no problem.
I guess you just put like y equals something about x. Then that's it.
Oh, okay. Yeah,
Yeah,
you just added your equation on it.
Yeah, then you need to add 2 equations because it's a broken line. It constitutes, it consists of 2 straight lines. So you need to put 2 here.
Okay.
Yeah.
That's very helpful. Thank you so much.
And I believe if we set it up correctly, the polynomial trend line will also show us the correct way of linear regression results. Can you confirm with me whether this the trend line I have here, the equation is the same as what you worked on in part B for problem 2?
Part B. Yes, it is correct.
Yeah. All right. So make sure that you select the correct series for X and Y. Notice that in my scatter plot, the income is correctly specified because it ranges from 50 to 250. And what's on the Y-axis is actually as intended as life satisfaction. It ranges between about 20 to 80. So if you selected these 2 series incorrectly, then of course you will get a wrong estimated equation for the polynomial regression.
Okay. Yeah. Thank you. I got this. Thank you.
Right.
Jerry, I got one last question if you've got a minute. I know we're running over time.
Sure.
Just on the model for, I can share my screen, but the model for question 2 part E, I tried to run the regression output. Hold on, let me reshare. So I ran the regression output, and this is what I came up with for the slopes. Does this look, am I on the right track with this output?
Yeah, looks correct.
Okay. I was sweating on that one earlier. Okay, thank you, Jerry.
Yeah, excellent. I know that at the first time, many of the things may not seem as obvious, so it takes some practice to get the correct answer.
Thank you.
Yeah, that's quite typical. When I practice new methods, it also takes me a lot of time in the beginning to understand what the potential and the correct form of results should be.
Thank you so much, Jerry.
All right, thank you for spending the time with me.
Thank you.
And good luck with the homework 4. And I believe next Monday, we will also have the second mini exam. Is that correct?
Yeah.
Yeah,
That's
I believe most of you did really well in exam 1. Although it's also true that most of the concepts are very straightforward. So I hope you can prepare as well as the first time for the upcoming exam.
Thank you so much.
Thank you, Jerry.
Thank you, Jerry.
Bye, everyone, and have a great night, weekend.
Thank you.
Thank you.
Thanks, Jerry. Bye.
Bye.